So today we're going to talk about the Pythagorean Theorem again. We've already talked about how to find the missing side of a right triangle, but we're going to focus in on how do you find solutions to word problems, so applications. So we've already talked about the theorem, we've already talked about the legs. The a squared plus b squared is c squared, where a or b is leg number 1, and then a or b is leg number 2. Doesn't matter which one's A and which one's B, but the hypotenuse must be C. So here's what I would suggest you do when you work with the theorem without pictures. 1, draw a picture. 2, identify the legs and the hypotenuse. 3, substitute what you know into the values. And then from there, just solve it. So here's an example. We have 10 and 13. They want you to find the hypotenuse. So you do 10 squared plus 13 squared is x squared. You solve, you get the hypotenuse is around 16.4. When you get your answer, you should be asking yourself, does that make sense? Your answer should be bigger than 13. Your hypotenuse is always along the side. So if you got an answer less than 13, that makes no sense. If you got something that was a little bit high, like say, I've seen kids say the answer is 269, that makes no sense. This is 269, but then this is only 10 and 13. And then of course, don't forget your units. This one's meters. Here's an example where you have a hypotenuse and a leg, and you have to find the other leg. So you're going to have to subtract off the leg squared and then square root. And so the missing side is 16 centimeters. Here's an example. We're going to find the measure of the missing side. And we know that the leg squared plus the leg squared is the hypotenuse squared. So I know that 28 squared, and that's how I'm going to put squared, plus 21 squared equals x squared. So solving that, if I type 28 squared in my calculator, or 28 times 28, I get 784. If I type 21 squared in my calculator, I get 441. Add those two numbers, 784 plus 441, that's 1225. And then of course, x cannot be 1225. You take the square root of 1225, and you get 35. So x is 35. So I could even put over here x equals 35. Does that make sense? 28 is the biggest number over here. You would expect it to be larger than 28, but not by too much. So 35 makes sense. Here I have the hypotenuse. How do you know something's the hypotenuse? You know it's a hypotenuse because it's always along the side, and I can see visually that this is the longest side, and it's always directly across from the 90 degrees. So I have my legs, I have x, I have 12, so I do x squared plus 12 squared, and that's going to equal the hypotenuse squared, 12.5 squared. From there, I'm trying to solve for x squared. 12 times 12 is 144. And 12 and a half squared is 156.25. I'm trying to solve for x squared, so I'll subtract off 144 on both sides. And I get x squared 156.25 minus 144, 12.25. I take the square root of both sides. The square root of 12.25 is 3.5. So I could say x equals 3.5. Now looking at this picture, this is what's called the short leg. This is the long leg. You would expect it to be less than 12. Definitely can't be bigger than 12.5. So this looks like if I broke this up into 4 pieces, it'd be around 3.5. So I think 3.5 is a good guess. Now we're into applications. So let's say you have a 14-meter long ramp. And just so you know, ramps are almost always hypotenuse, because ramps, in order to be a ramp, you want it to go up something or to go down something like a staircase. So it doesn't make any sense to have the ramp on the ground or a ramp going straight up and down. That just doesn't make sense. So almost always your ramp is going to be your hypotenuse. So a 14-meter long ramp is put at a dock that is 3 meters high, and they want to know how far is the bottom of the ramp from the dock. And so here they drew a rough sketch, and you don't have to draw a dock, you don't have to draw a ramp, but you at least need to draw a triangle. And so we know the hypotenuse, which is 14. That's why they put 14 squared. And then we're trying to find 3 squared plus what squared is 14 squared. And they chose to pick A as the variable. So 3 squared is 9, 14 squared is 196. Subtract 9 from both sides, that's 187. Take the square roots, that's 13.7. So I would say the bottom of this ramp is about 13.7 meters from the dock. Example 6, a ladder is leaned up against the wall. Again, a ladder is almost always going to be your hypotenuse, because you don't put a ladder straight up and down usually. If you do, you probably will fall off. And there's really no reason to climb a ladder that's on the floor. So more than likely the ladder is the hypotenuse. And what I'm going to do real fast is I'm going to do my best. I'm going to hit pause, and I'm going to draw a rough sketch. So I drew a ladder, I drew a wall, and it says the bottom of the ladder, that'd be right here, is 5 feet from the wall. So I measured that as 5. Then it says the top of the ladder, that'd be right here, reaches a spot on the wall that is 12 feet off the ground. So how long is that ladder? So we have our leg, we have our leg, we have our hypotenuse. How do I know this is 90 degrees? Well, the ground makes a 90-degree angle with the wall, because when you build a wall, you build it straight up and down. So this is 90 degrees. So I set it up. I say 5 squared plus 12 squared equals x squared. 5 squared is 25. 12 squared is 144. If I add those, I get 169. Take the square root, and that's 13. I should have known this already. This is one of those Pythagorean triples. When you see 5 and 12, the other number is always 13. So x is 13, so I would say the ladder is 13, and my unit is feet, 13 feet long. Erica drives 25 miles south and then drives east. After a while, it is determined that she's 60 miles diagonally from where she started. How far east did she drive? One thing that might help, in case you forgot, is that your directions, at least on a piece of paper, we call this north, south, at least on paper it is, east, and west. So we'll start off with Erica. Erica's in a car. I'm guessing she's driving. And so we'll draw ourselves a car. So there's her car. So what she's going to do, so she's going to drive 25 miles south, and then she drives east, so that'd be to the right. And it's determined that she's 60 miles diagonally from where she started. She started here, now she's here. So we know that that is 60. And we know this is 25 because they told us that she drove 25 miles south. So how far east did she drive? So this would be my x. I set it up. This is my hypotenuse. This is the right angle. North, east, south, and west makes 90 degrees. So my formula would be 25 squared plus x squared equals 60 squared. 25 squared, 625. $60 squared, 3,600. Subtract off 625 on both sides. And I get x squared, 3,600 minus 625, 2975. Take the square root. And I get 54.54. Now they didn't tell me how much to round, but nobody cares that you drove 54.54 miles. I mean, most people are going to say, you know, they're going to round and say, Erica drove. And you know, it's kind of your choice if you want to round up or round down, but I'm going to use, because that's bigger than 5 or bigger, I'm going to say 55 miles. Okay? It's not really going to matter, the 0.54 in this problem. So Erica drove 54 miles.